This video will explore the multiplication of complex numbers. One thing that you need to remember when you are going to multiply complex numbers together, if you do have imaginary numbers, you will need to use the fact that I squared is equal to -1. Now we typically substitute this in once we've done the multiplication in the last couple of steps of simplifying the problem. Let's look at a real basic example first. In this problem, we've got the square root of a negative number times another square root of a negative number. Now this example will show you the importance of bringing I out in the beginning of the problem. Before you start multiplying, before you do any operations with the square root of a negative number, you should always remove that imaginary part first. So take the I out to get rid of your negative under the root. Can't really simplify that, so I'm going to leave it as is. Same thing over here. Take an I out. And then what you're going to want to do is multiply these two together. So we multiply the I times the I because we're multiplying two rational expressions together. So we multiply what's out in front, the coefficient, first. That gives you an I squared. And then we multiply what's underneath the root, the 2 and the 5. Again, I'm not going to be able to simplify the 10, the square root of 10 that's underneath, but I can do something with that I squared. I can use this right here, the fact that I squared is equal to -1. That will give me a -1 in front of my square root of 10, which of course we can just then write as negative square root of 10. For our answer. Okay, so that's just a real basic multiplication problem. Let's try something that's a little bit more complex. In this example, we are going to multiply a single term imaginary number, 3i, times a two-term imaginary number in standard form, 4 plus 2i. And as with the addition and subtraction, I kind of acts like a variable in these problems. So we will distribute the 3i to the terms that are inside the parentheses, okay? So first, 3i times 4 will give me 12i, just as if that were an x instead of an I, okay? Treat it like a variable. And then 3i times positive 2i will give me a plus 6i squared. Okay, and now you're going to use the fact that I squared is equal to a -1 on that term. If we were to multiply positive 6 by -1, what would we get in that second term? That would make that a -6. So what happens with the I squared is it effectively changes the sign on whatever term it's in. So we now have 12i minus 6, okay? So we've used the distributive property. We have plugged in -1 in place of I squared. And now here at the end, we do want to write it in standard form. So in standard form, we put the real part first and the imaginary part second. -6 plus 12i is our answer to that example, okay? So that is a single term times a two term. Let's look at two binomial style complex numbers multiplied together. 1 plus 2i times 4 minus 3i. You'll multiply this out either by using the distributive property or by using FOIL if you are familiar with that technique. That's what I'm going to do. FOIL just gives you a way to keep up with your distributions. F stands for first, so first term times first term would give you 4, 1 times 4. O stands for outer, so the outer terms 1 and -3i. I stands for inner, 2i and 4. And then L stands for last. That's going to be my 2i times my -3i, which gives me -6i squared. Okay, so here again we look at this. -6 times -1 will give me a positive 6. That's generally the way I do it. I just kind of mark it off to the side. Combine your two real parts. 4 plus 6 is 10. And then your two imaginary parts. -3i plus 8i will give you plus, or positive, 5i. It's already in standard form. I don't have to move anything around. So 10 plus 5i is my answer. Now, one more little trick that we're going to look at before we leave the multiplication subject is something called a complex conjugate. You'll need this to work the problems that are coming up in the next section, which is division of complex numbers. And what complex conjugates are is it's two complex numbers, two imaginary complex numbers. One will have one sign on the imaginary part, and the other complex number will have the opposite sign on the imaginary part only, okay? So they're the same two numbers, but with opposite imaginary terms. For example, 2 minus 3i and 2 plus 3i. Another set of complex conjugates might be 4i and negative 4i. Now, real part alone don't have conjugates. It's only the imaginary part where we have a conjugate. Another example, 1 plus 6i and 1 minus 6i. And you get the general idea. The real part stays the same. The imaginary part changes. Let's take this last set right here, and I'll show you something neat about the product of complex conjugates. Let's say we want to multiply 1 plus 6i by 1 minus 6i. And we can use FOIL on this. So I've got 1 times 1, 1 times negative 6i, 6i times 1, there in the middle on the inside. And then for the last, I've got 6i times negative 6i, negative 36i squared. Now watch what happens when I go to simplify this. The negative 36i squared becomes positive 36, right? Negative 36 times negative 1 from the I squared. These two terms in the middle are going to add out to 0, so I'm going to lose all of my terms that have an I, or I'm going to lose at least the I out of all those terms. So what I've got left is all real. I've got the plus 1 at the beginning and the plus 36 at the end, so I wind up with a 37. When you multiply complex conjugates together, you will get a real number, okay? When you multiply complex conjugates together, you'll get a real number. And like I said, we will use that in the division of complex numbers that's coming up at the end of this section.